Today, we're going to do something a little bit different, and we're going to have a look at the project that I'm currently working on. Now, this project is a very high level. If you know the Haystack framework, it's to implement a new document store within that framework. If you don't know it, no worries, I'm going to explain it. So, I left a couple of notes, which you can see here, to remind myself what I actually want to talk about in this video. So, to start, I want to just give you an overview of what is ODQA, or Open Domain Question Answering, and the three components in that. You've probably, if you watch a couple of my videos, you've definitely seen me talk about this before. But for those of you that don't know it, I'm just going to very quickly go over that. And I'm going to explain how Haystack fits into that. So if you already know what Haystack is and you already know what Open Domain Question Answering is, you probably just want to skip ahead a little bit. It's up to you. I'll leave some chapter markers in the timeline so you can skip ahead if you want. And then we're going to have a look at the current document stores within the Haystack framework, and why I'm going to implement a Pinecone document store. And then we're going to have a look. So this is probably kind of relevant, especially if you want to contribute to open source. I'm going to just go through, set up my own Git repo for this, and set it up so that it works with the other official Haystack Git repo as well. So I'll show you how you can do that, how you can set up your Git for open source projects when you're planning on contributing. And then we'll have a look at the document stores, or the specific code in document stores in the Haystack library. So yeah, I think it's a different video, but should be interesting. Oh, and one last thing, actually, if you do want to test document store, go ahead and you can git clone from here to your own local machine. So I'm going to git clone the above, okay, and then you want to, within that same repository, so let's say that downloads it to your documents Haystack folder. Navigate to that folder in your terminal window or command line, and then you just need to write pip install dot, right, and that will install this version of Haystack, and then you can test the Pinecone document store. Now I'll show you how you can start doing that. So if you do want to test that, and maybe even if you want to contribute and you see some terrible code that I've written, you want to make it more efficient, please do go ahead and do that. So let's start with a quick overview of Open Domain Question Answering and the three components that we see in there. So I'm going to assume you've already seen some of my videos on this, or that you're aware of Haystack and Open Domain Question Answering. So I'm going to be really quick. So Open Domain Question Answering, or ODQA, it's basically you have a load of text data or some other data in a database somewhere, and let's say Wikipedia, that's a good example. So we have our Wikipedia articles over here, we call this wiki, and we ask a question. So we have, let's say, like a search bar like Google over here, and we ask a question like who are the Normans, ? And then we press search, right? We have, in Wikipedia, we have the answer to that. Okay, the Normans are people from Normandy in the north of France. But we need a way of translating that question into that specific little part of information, and pulling that from our larger database. This can contain millions or more of paragraphs of information. So how do we pull the right bit of information? So this query gets converted into a vector. using what's called a retriever model. So we go into our retriever model, it's converted into a vector. All of these Wikipedia snippets are also vectors. So we go to our database, this is a vector database over here, and we compare our query vector, which we'll call XQ, with all of our context vectors. And that will return a set of relevant context vectors. So we'll call them XC. And these context vectors are quite big, they're like paragraphs. Now, we don't need a paragraph of text to tell us where the normans are from, or where the normans are from. We just need a small snippet. So we pass this into what's called a reader model over here. Also passing in our question. And that reader model is going to take our context. So let's say this is one of them. It's a really long piece of text. And it's going to say, okay, the specific answer is here. Okay, so it's going to say north of France or Normandy. Okay, and that's open domain question answering. Super, very high level. That's how it works. Now, how does Haystack fit into that? So I will show you. It makes most sense to just go to their repo. Okay, and we actually have this little about here, which is nice. Open source NLP framework uses transformer models. We all know what they are, and allows us to implement production ready search, question answering, semantic document search, and summarization. Okay, so it's quite a lot. The main bit we're focusing on, at least here, is this kind of like search and question answering. So this is exactly what I just showed you. Right, so we're entering our question. This produces a query vector. We press search, and then we get these contexts, which are the long chunks of text, and then the answers, which are those little smaller snippets that you saw that are highlighted. All right, so the retriever and vector database gets those big paragraphs. The reader model gets a little answer. Okay, and Haystack is basically a way to do that, and it's incredibly easy and straightforward. Like, you don't really need to know too much about open domain question answering. You probably don't even need to know that it's open domain question answering, and you can implement this pipeline and get something that works really well. It's honestly a very good framework for this sort of thing. So earlier on I mentioned there's this document store thing. Document store is basically where you're storing the information. So earlier on I said vector database. Document store is basically, we can see them as being both the same thing, just different names for the same thing. Now, we kind of have this overview here. We're not going to worry about the indexing pipeline so much. That's basically just, you get your data and you convert it into a readable format for your document store. But we do have our document store, and then we have the search pipeline. So we have the retriever and then the reader over here. We also have a generator. I haven't mentioned that. We're not going to talk about it here. We get our answer. But let me show you an example. So we'll go to here, better retrieval via DPR notebook. Let's scroll down a little bit. Okay, so here we're using Feist as a document store. Okay, so this is where we're going to store all of our information. Scroll down a little bit more. And over here we're pulling in these files, which is a wiki. I think it's the wiki for Game of Thrones, like the fan wiki or something like that. It's just all the text from those. So you have loads of paragraphs talking about Game of Thrones and this random like trivia about it. So we've got the data and we write that into our document store. Now, we've written the text to our document store at this point, but not the actual vectors, because, like I said, there's a vector database behind this as well. And what has happened here is we're storing text of the context, or of that Game of Thrones wiki data, that our database, but we've not converted them into vectors yet because we need a retriever model to do that, and we can't search until we have those vectors. Okay, because we're searching using a vector search. So what we do is initialize a retriever model here. Here they're using DPR. You can use DPR if you want. I would look into retriever models on in-sentence transformers. Personally, it's probably more efficient, and generally I think the performance is better as well. But in this example, it's just DPR. And then, so we initialize that DPR retriever model and then update the embeddings. So we create the vectors from the text that we've already pushed to our document store. Okay, and this creates the vectors, stores them in the vector database, which is FAISS in this case. Although FAISS is just an index, it doesn't have all of the other stuff that would make it a vector database, but I'm going to just call it that for the sake of simplicity. And then we have a reader. So the reader model is that the final part that you saw. So after we have retrieved a set of relevant context vectors, we pass them through our reader model, and that extracts a specific snippet of an answer. Okay, like a few words that answers our question. And then, so Haystack allows us to do all of this super easy. I don't know how many lines of code that is. It's, we have our imports, and then there is something like 4 lines of code to initialize all those components. And then we are initializing a extractive QA pipeline. So open domain question answering, we are extracting the answers from a set of contexts. That's why it's extractive QA here. And in that pipeline, we just pass our read and retrieve. We don't need to pass the document store or the vector database, because if we have a look up here, the retriever already contains the document store. Okay, so it's already in there. Okay, so we've initialized the pipeline, and then we can ask questions. So we have this pipeline run query. You created Dothraki vocabulary. We have this top K. We won't focus on those right here. It's just how many answers to return, basically. And then we print the answers, although in this notebook, we don't actually see them print the answers. I have an example, so I'll show you quickly. Okay, so I'm just going to come down here, and I have an example. This is with what I built so far, the Pinecone document store. It's not finished yet, but it is kind of working. So same thing again, extractive QA pipeline. I've just copied this code from that notebook you saw. And we'll come down here, and this is the bit that we were missing from the other one. So print answers, prediction, and we get this. Now, in this example, it's a really bad answer because I've only uploaded like 6 contexts because I was just testing it. But you'll get something like this. So you'll get an answer. It's like, who created the Dothraki vocabulary? And it's just pulling out someone's name, because it's like, it knows that you're asking who created something. But there aren't any good answers here. So it's like, okay, that's all I can give you. So again, Elio Garcia from here. Okay, so that's the sort of format that we're expecting, the sort of workflow when you're using Haystack, which is, it's really good. It makes this very easy, and Haystack is all about making open domain question answering really simple, and that's kind of why I want to bring Pinecone as a document store into that as well, because Pinecone makes vector search incredibly simple. From what I can see, simpler than any other option out there. So that's why I think they go together very well. And you get good performance and everything else with Pinecone as well. So there's a lot of benefits to including it. Now, what I want to just show you quickly is, okay, how do you get started when you're setting up, when you're hoping to contribute open source project, how do you set that up in Git? So, I mean, you can see here I made this little chart, which kind of explains why why the setup is different. So you have your local machine where you're going to do development work. Typically, you would only have what you wouldn't have this like Haystack repo upstream thing. You would just have this when you're working on a project. Okay, you have your remote repository, your origin, and you pull and push to your origin. It's pretty simple. For if you're planning on contributing to a project, it's a little bit different because you need to fork your new repository. So you have the official repository, and then you have your forked repository. That becomes your origin. And then you pull and push to that origin that's been forked. But you also, if you're working on this for a long time, you want your repository to stay up to date with the upstream or the official repository. So you need to also set up an upstream remote as well, so that you can pull and merge from that upstream to your local and your forked repo to keep it up to date. So let me show you quickly how you might do that. Okay, so on my right, I just have terminal window, and on the left, I have Haystack repository. We're on that notebook we were on before. So we go to the top level. First thing you need to do is, where are we? So let me come to here, view code, no, make it bigger, here we go. So we're on this green button, and we are going to, no we're not, we're going to fork here. Okay, I already have a fork, so I'm going to, fork again to a different account. Okay, I'm not going to do that, I'm just going to use this one that I've already created. But anyway, you fork, it will create a fork on your account. Okay, and then you go to that fork. So actually I can go up here, just replace DeepSet AI with my username. Okay, and you can see I also fetch upstream here. You can also use that. But we're gonna set it up on Git, so you can see how it works. So this is my personal version of Haystack that I am modifying. Right. So what I want to do is code. I'm going to copy this, and I'm going to come over here. I'm going to cd documents. I think that's fine. I'm going to git clone that. Okay, so it's going to clone Haystack onto my local machine. It's actually going to take a really long time, so let me just set up for another random project. So can I cd Haystack? Okay, I'm just going to make the Haystack, no problem. I'm going to cd into it. I'm going to pretend it's a repo. So I'm going to get in it, okay? And let's just pretend this is now our Haystack repository that we've just done a git clone for, okay? So first thing we need to do is we need to add our remote. So git remote, add origin. So the origin remote is going to be our personal like repo. So it's here, this one, James Callum Haystack. So let me copy this, pull it into here. And then what you need to do is set up a upstream remote. So git remote, add upstream. And this is going to be the original. So if I go to here, so DeepSet AI Haystack, so this is the original repo. I'm going to copy this and paste it in here. Okay, so now I think it's git remote v. Yeah. So you can see the origin of the upstreams, and that's what we want. So now, whenever there's an update to the upstream that we want to merge with our sort of the version of the project we're working on, we would just write git pull upstream. Okay, and that will pull any updates, and we'll have to merge and commit everything into our own repo. At the same time, if let me move out of this one and move into the real haystack that I'm actually working on. So projects haystack. Okay. There's nothing I want to change at the moment, but what I can do is I can git pull upstream, and maybe we'll see some changes. I'm not sure. I think I did it yesterday, so maybe not. Oh, maybe. Yep, there is. Okay, so this is actually going to update everything. Okay, so I need to actually git pull upstream master, I think they use. So not just git pull upstream, need to specify the branch as well. Okay, and it is up to date, so there's no issues there. Okay, so that's pretty good. But obviously, when we are committing things, so git commit to do everything we're doing, and then we do a git push, we don't go to upstream, we go to origin. Okay, and we should also have a branch checked out as well. So we would git checkout. You can actually see mine here. If I do git status, you can see I'm on the pinecone.store branch. So when I've committed some changes and I want to push that to my repository, I'm going to do git push u origin, and then I'm going to do pinecone.store. Okay, and that'll make changes in my own repository. So yeah, that's really it for the when you're working with open source, you have that, so you're able to pull from the original repository, which is this DeepSet haystack, and you're also working and pulling and pushing to your personal version of that repo. So I thought it's useful, it might be useful for someone out there, and that's really how you get started with your project. So once you have that set up, you have your haystack repository, which I'll go and open in VS Code over here. Okay, so this is the haystack repository, or the local version of it. And in here we have the document stores. Okay, and there are a few, so let's go through those. Now, I'm not saying you have to use Pinecone or anything like that, but I'm just saying why I want to include it. So we have DeepSet Cloud, which I think is very new. I'm not even sure it's fully implemented yet. I'm not sure. So I can't say anything about that. I have no idea. I know that's DeepSet's offering, and I'm pretty excited to see what that is. To be honest, I'm sure it's very cool. Elasticsearch, and now with Elasticsearch, you're not really doing a vector search. You're doing like a sparse retrieval followed by a dense vector re-ranking. So yeah, you can use this, but you're not doing an actual sort of semantic search or full open domain question answering with this. So it's not great. Vice, you have to handle the infrastructure and stuff yourself. So I'm not too keen on that. So yeah, Vice is good, but you have to understand what you're doing. Otherwise, it's a nightmare. Especially if you have a lot of vectors. If you get to like 1 million plus, Vice can be difficult. You have Milvus. Milvus is, I think they can host stuff for you. You can definitely use that. I found it difficult to set up, and for me, I want everything to be super simple and easy and just good. I struggled with Milvus a bit, so you can use it, of course. I didn't find it that great, and then I had the same thing with Reaviate. Again, I hear good things, but you're going to struggle a little bit. Another thing on these two, so I think Milvus and Reaviate are the closest you're going to get to Pinecone at the moment in Haystack, but they also they don't have the full metadata filtering capabilities of Pinecone as well. Metadata filtering in Pinecone is very good because they have something called single stage filtering, not pre or post filtering, and it is definitely, I think, it outperforms the others. So that's another thing to consider as well. So there are a few document stores that you can already use. There are others as well. There's Memory, GraphDB. I haven't used these, so I can't comment on them. But yeah, they're the current offerings that you have. And then we have Pinecone, which I'm currently implementing. Okay, now let's have a look at. I want to have a quick look at the sort of core functionalities. We already really had a look at them, but I just want to cover them very quickly again. So basically what I'm going to need to work on to actually get this working is write documents or initialize initializing your document store. So if I open this more, okay, so you can ignore this, it's not relevant. So this bit here, got a document store, Pinecone document store, initializing that with a API key environment like you would with Pinecone normally. Okay, so that's just initializing your document store. Like how does that work? And that's pretty simple. It's just the init over here, and we're connecting to it. Nothing special there. And then the first thing that you saw before is write documents. So this is where we're writing text, and this is we kind of have to do something. We can't just use Pinecone for this because we can have very long chunks of text, and Pinecone doesn't accept more than 5 kilobytes of metadata at the moment. Okay, so we can't store long pieces of text in that metadata. So we actually have to use a local SQL instance to store those big contexts, and then the smaller bits of metadata we just throw into Pinecone. So that's basically populating our SQL database. Like I said before, we just initializing a retriever model. It's not, I haven't had to do anything there. And then we update embeddings. So this is where we're looking at those contexts, converting them into vectors and storing them in Pinecone. And then there's just the querying. So we're asking a question here. Now you can't see here, but this is actually calling a method called query. And that's a standard method. So you have to, the way we have to implement everything in our document store has to fit with the standard Haystack ways of doing things. And then we have to be able to delete things, delete documents, get documents by IDs, and so on, and also include metadata, which is important. Now, we're not going to actually dive into details of that in this video. I want to do that in maybe the next video. We'll cover a lot of that stuff. But for now, just an overview of what there is in there, how all this works, why we'd even want to do it in the first place, and so on. So, yeah, I don't think there's anything else I want to cover in this first video. Well, let me check. Yeah, that looks like everything. So, yeah, that's everything for this video. We'll I think explore this in a lot more depth in the next video. So that should be pretty interesting. If you do want to contribute and help implement this, please feel free, go ahead and do it. So over here, this is a repo at the moment. I'll update in the description if that changes. But yeah, that would be really cool. So, and as well, you can just go ahead and test it. That's also really helps. So yeah, that's everything for this video. thank you very much for watching. I know it's a bit different. It's not really a tutorial. It's more just like walking through what we're doing, but I hope it's useful to see, how this sort of stuff might work. Maybe, maybe it's something that you want to do as well. So that would be cool. Anyway, thank you very much for watching. I hope it's been useful, and I'll see you in the next one. Bye.